Good afternoon, everybody. How are we doing today? Or I should say, how are we doing, Emily and Hannah? I think everybody else is really just going back and watching the videos. That's what it seems like, because I have homework assignments being turned in from other people. What's going on, Em? Emily, I just wrote up your whatchamacallit that I forgot to do for this last week. Your scholarship. Hannah, as of right now, we had to leave Archie at the vet, and he's got to stay there for the night. He had like 104-degree fever, and they're not quite sure what is wrong, so they wanted to hold on to him. But he wasn't eating for the last day, and he was dehydrated as well. He wasn't drinking water, so we're hoping everything's good. They ran a bunch of tests and everything came back negative. So the last thing that they might have to do is run an X-ray to see if there's anything that he possibly ate that could be like clogging up his stomach, because he's been having a lot of diarrhea and he's been throwing up a lot. So it's either that or we put him on the dewormer medication and he might be allergic to it. Yeah, that's what I told my wife. She's upset right now, but that's right now that is the best bet, is having him at the vet. But yeah. Yeah, it is. And when I say 104-degree fever, that sounds like really, really bad, because for humans, like if you go over 100 degrees, you're sick. For puppies, it's normal for their temperature to be about 102, 103 degrees. It's when it starts getting higher than that, that's when you have to start getting worried. So he could just have a small viral fever, but they just wanted to monitor it because he hasn't eaten in the last day or two. So they just want to be safe. I know, like, he gets into stuff when he's running in the backyard. He had or not a virus, but when they looked at his poop, they found a disease that's only found in rabbits, and it's because he got into rabbit poop in our backyard. It's not harmful to dogs, but it was just funny to hear. So he probably got into something, and they just need to get it out of his stomach, and he'll be okay. But he should be fine. But we'll hear back around 8 o'clock tonight is when they're supposed to be calling us. So we'll go from there, and I'll keep you guys posted. Today I'm only this lesson isn't even going to be that long. Everything that you see right there is the entire lesson. So what I think I'm going to do is I'm just going to do the warm up and example number 1 with you guys today, and then I'll do example 2 and example 3 tomorrow. And that's all we'll do for this week. All right. So the warm up's going back to some old school stuff. At least part A is. Because when you multiply, you just have to make sure that you're multiplying the coefficients and you're adding your exponents. So in this case, we are going to, I'm going to use a smaller highlighter. We're going to multiply the 5 and we're going to multiply the negative 3. So that's just normal multiplication. So that's going to be negative 15. And then we have the x's, which is a little bit different because this is where we have to add the exponents together and keep the bases the same. So since they both are x, it is going to stay x. But if you add a plus 2a plus 4, the a's just add together and become 3a. And since we couldn't add the 4 with anything, we just leave it. And that's it. So that's going kind of old school, just making sure that you remember your exponent rules. Even though it's a variable, you can still add them together up top. There's nothing wrong with that. Part B is more like what we've been doing in the last couple of lessons. This would have been lesson 7. So this is the composition. So when you do composition, all you are doing is making sure you're following the inside and outside of the function. So g of x is on the inside, so that is what comes first. So you have to solve g of x. But what you're going to realize is g of x is just equal to 10 plus x squared, and we can't solve that. So that is the solved version of g of x. We can't do anything else. So now we just have to move to the outside. So the outside is f. So I have to take my answer for g, and I have to plug it in for that f. So since the answer for g of x was 10 plus x squared, I can plug that in, and now I can substitute it in for the function f of x that we have up here. So if I plug it in, I'm just going to include my parenthesis, and then all I need to do is simplify it down. So I can distribute the 5, and then I can combine like terms. So 5 times 10 would be 50. 5 times x is 5x squared plus 3. So I'm going to have 5x squared plus 53. And I just flipped it around because I like putting the exponents first. Okay, so the first two are just review problems. Nothing too crazy. Just making sure that you guys have those steps down. Okay. As far as the next part goes, so we call these rational functions. We're going to be doing graphs with rational functions. We have never graphed anything like this in the past, so this is new. We're going to be doing something. Eventually, it's going to be called a hyperbola, which I have down here. So a hyperbola is a new type of graph that we haven't done before. They're not going to be too crazy, especially because we have access to a calculator. So first of all, I have to review a word that was called asymptote. And we talked about asymptotes. Oh man, when did we do asymptotes? I know we did it like a month or two ago. An asymptote just means there's a hole in the function, or there's no solution at that certain value. So when you have an asymptote, it just means no solution. That's probably the best way to put it. Now, these type of functions that we're looking at, so we have y equals -2 over x plus 3 minus 1. There are two different types of asymptotes. And I'm going to come over here and I'm going to look at this form. So here is the equation for a hyperbola. I guess I should have color coded a little bit better, but whatever. That is a hyperbola. That equation, I'm not going to have you guys memorize it. This is more just an introduction in case if you do have to do something like this in your future. So if you see anything in that form, that's called a hyperbola. In order to find the asymptote, in order to find the answers that don't work, we're going to look at these two little things I have written here. One says that x is equal to h, and the other one says that y is equal to k. So both of those will give you an asymptote on your graph. That means there's going to be no solutions at those values. So the first part says x is equal to h. Well, h comes as the second number on the bottom of your fraction. Up here, if you look, the second number says that it is +3. Now, if I were to look at this, this says -h, right? Over here it says +h. So when we go to find the x value, we have to do the opposite sign. And the reason why is because if you look at the bottom of that fraction, x plus 3, what it wants to know is, hey, what do we have to make x in order for this fraction not to work? So there was a word that we said undefined. It means that the denominator is going to be equal to 0. So in this case, the only way we can make x plus 3 equal to 0 is if we make x equal to -3, because it's got to be the opposite value. And so that's all we're doing. We're just kind of looking at this denominator for the h value, and we're just saying, hey, what's going to make that number 0? And in this case, it's going to have to be that -3. So it says x equals h, or x will equal -3, because that's what h is. As far as the y asymptote, so we found the horizontal asymptote. Horizontals go sideways. Now what we're going to do is find a vertical asymptote. Okay, so we have y, or I just said it backwards, but whatever. When we do the picture, it will make more sense. So now when we do y equals k, if you look at the picture, or look at the graph up here, k is just the value that comes at the end. So it's just whatever number's here at the end, and in this case, the number that's in the end for this graph is -1. So in this case, we can say y is equal to -1. We're just substituting right in. So now all I'm going to do is I'm going to graph all of this. We're still going to use the calculator. I'm just trying to break down what an asymptote is again, just do a little review with it because we haven't done it in a while. So what I'm going to do with my graph is I'm going to draw in my x and y axis right down the middle. So I'm going to say this is the y axis, and I'm going to say this is the x axis. Now, the two answers that we just did first are the asymptotes. They're the answers that don't work. So I'm going to go over to x equals -3, which is going to be right here on our x-axis over to the left. And all the values at -3 are not going to work. So what I'm going to do is I'm going to draw a dotted line going straight down that -3. What we are drawing is an asymptote. The last time we probably did asymptotes is when we did quadratics. Okay. So now -3 has no solutions. We also have to do one at y equals -1. So now I'm going to go to the y-axis. I'm going to go down to -1. And once again, I'm going to draw a dotted line going through -1. So there's no solutions that are allowed to fall on either one of those dotted lines. Okay. So now all I'm going to do is I'm going to show you guys how this graph works. I'm going to show you guys with the calculator because it's so much easier to do it with the calculator. I'm going to type in that original function now. So I have I have a fraction, 2 over x plus 3 minus 1. And once I get that typed in, I'm just hitting graph. And I might have to screw around with your graphing calculators a little bit. Hold on, I'm getting a phone call. It is not important. So now that we got this typed in, you may have something a little messed up like mine. What I recommend doing first is on the iPad calculator, if you need the graph to show up, hit the zoom button, which is located, I can't really point to it on my calculator, but it's down here. It's right above my little red dot at the bottom of the screen. So you're going to click on that zoom, and you always want to go down to Z standard. Z standard will always take you to your main screen. So once you get to the main screen, you're going to see that dotted line that we drew on our graph, but it's only showing us the vertical dotted line. Your calculator will never show you the horizontal, and that's why I always recommend you have to find the vertical and horizontal asymptotes by hand first, and then type it into the calculator. So now that we have this typed in, what you guys can see, and I don't know if I can do, I could put, oh, that's right, I could put a little dot on here and I could follow it along. If you guys look at this graph right here, it's going up forever and ever and ever, and it's never crossing, oh my gosh, it's very hard to move. It's never going to cross that dotted line. If you look down here, the same thing's going to happen, even though we don't see the dotted line there. If I move my graph over to the side a little bit, you're going to notice it's never going to cross -1, just like we said in our picture. So what we can do, and this is the easiest part now, we're saying that this line is up here and it's never going to cross that red dotted line, and then it's going to bend down and never cross that purple line. And all I'm going to do is just put two little arrows right there. And now we have to do the other side, and what you should notice is that other graph is going to be diagonal to the one that we just did. It's never going to cross the dotted line down here. So if I kept going down forever and ever and ever and ever, I don't know why it's not letting me click, it's never going to cross that dotted line. And same thing up here, it's never going to cross -1 on the right side. So what I'm allowed to do is just draw in my line to the best of my ability, because I know it's going to fall within that range on our calculators and on our grid. What we just did is we graphed a hyperbola. A hyperbola is normally going to be separated just like we see here, and they're always going to be diagonal from each other. So if I drew one in the top left, that means the other part of the graph is going to be in the opposite corner in the bottom right. Okay, so today was more or less just an introduction with these. We're going to do some more of these tomorrow. But yeah, this was just an introduction to a hyperbola. We're going to do another one right here in example number 2, and then we're going to find domain and range with it. And then we got even another one on the back with example number 3. So when you guys attend the lesson tomorrow, it's going to be the same kind of stuff. It's just going to be more practice with it. And hopefully that will better prepare you guys for the homework. Don't worry about trying to do homework number 9 tonight. I know I mentioned this multiple times. Math 12, you guys are not going to have lessons on Fridays. So this homework isn't even going to be due until Monday next week. So I'm always going to make an assignment due pretty much. It's either going to be a Wednesday or a Thursday you're going to see an assignment due, and Mondays is when you're going to see assignments due. Okay? But, I mean, as far as the people that are in here right now, I'm not worried about you guys. It's the other people that are going to be coming back and watching these videos. Make sure you guys are paying attention to that. And if you guys got questions, let me know. Okay? Em and Hannah, are you guys okay? I know what we just did in example number 1 there was a lot of like new stuff I just threw at you. So I just want to make sure you guys are feeling comfortable. And then we will, like I said, just do some more practice with it. All right, cool. Are you guys keeping sane? Doing anything new? Emily, I don't know if did I ever ask you if you got accepted to New York? Yeah, I'll definitely keep you posted, Hannah. Like I said, we find out something more tonight. So I'll definitely let you guys. You did? Congratulations. You didn't find out before all this, did you? I don't remember if we had the conversation in class. Or I say in class, in school. Did the emoji thing. You don't like the crying? You're just drawing a lot, that's it. Yeah, this is the only crying one I have. I don't have any other crying ones. I don't think I do. Oh, I do. I have a monkey one that does it too. This is all I'm doing now is just looking at all my emojis. Every other math student that's going to come back and watch this video, they're going to be like, Sadler, what are you doing? But, all right. Well, I'm going to sign off. Yeah, yours looks like a robot. Wait, mine looks like a robot too? Mine's a monkey. But I'm going to sign off. I'm going to go hang out with my wife because I know with Archie not being here, she's probably lonely after we've had this dog in the house for the last like week or 2. Oh, I got you, Hannah. But, all right. Well, you guys have a great evening. I will see you guys tomorrow, same time. Like I said, we'll just do those 2 questions. So I will catch you guys later.